Hi all. So tonight we're going to go over from the Blue Book numbers 1 through 33 odd. We just talked about it in class. Either I wrote the wrong thing, you wrote the wrong thing, or we both wrote the wrong thing. But it shouldn't happen again. So just kind of bear with me and we'll get through this together. So for number 1, I'm just going to read it. That's why I'm looking over to the side. What do we mean when we say that motion is relative? What is everyday motion usually relative to? And we can answer that by saying basically motion depends on your frame of reference. If we're dealing with a car driving by, the driver seems to be moving fast if we're sitting on the side of the road. But if we're sitting in the passenger seat, the driver doesn't appear to be moving at all, even though we're both moving. So we say that motion is relative to where you are, a fixed point in physics class. So when we talk about a ball, we're standing over here on the side, and we're talking about a ball that we're throwing, and we're looking at it kind of straight on. So that's what we mean. Motion is relative. Okay. Number 3, you walk across the room at 2 kilometers per hour. Express this quantity in terms of abbreviated stuff. Not year, it should be 2 kilometers per hour. You walk across the room at 2 kilometers per hour. Express the speed using abbreviated units. There you are. Now, these are not exactly the units that we would be using for a physics class, but these are abbreviated units, and we'll get into the correct units in a few minutes. 5, does speedometer of a car read instantaneous speed or average speed? The speedometer of a car reads how fast you're going at that particular second, which is the instantaneous speed. The average speed would be the entire distance, the entire time that you took to go that distance, and you divide the two. Number 7, if the speedometer of a car reads a constant speed of 40 kilometers an hour, can you say that the car has a constant velocity? Why or why not? I would say no. Unless you know the car is going in a straight line, the car could be changing direction and therefore would be changing velocity. Therefore, it would be accelerating. Number 9, what quantity describes how quickly you change how fast you're traveling or how quickly you change your direction? That would be acceleration, as we just talked about in number 7. Number 11, what's the acceleration of a car that travels in a straight line at a constant speed of 100 kilometers an hour? The acceleration of something that is traveling with a constant velocity is 0 meters per second squared. You see that is another way of writing second squared. The little caret is number 6 on a keyboard, and if you hit Shift 6, you get that thing, and that means an exponent. So there you go. Number 13, I got a do out for us. So by how much does the speed of a vehicle moving in a straight line change each second when it's accelerating at 2 kilometers per hour seconds, or 4 kilometers per hour seconds, or 10 kilometers per hour seconds? So let's just take one and hopefully it'll make sense for the other two. If your acceleration is 2 kilometers per hour seconds, it's really saying it's 2 kilometers per hour every second. So the acceleration is 2 kilometers per hour per second. That's kind of what you're saying there. So every second it changes by 2 kilometers per hour, or 4 kilometers per hour, or 10 kilometers per hour each second. That's what the unit means. I know it looks weird, hours, seconds, but it's the same thing as writing 2 kilometers per hour per second. So there you go. 15. What is the meaning of free-fall? It's projectile motion where only gravity affects your object that's falling. 17. For a freely falling object dropped from rest, what is the acceleration at the end of the 5th second, the 6th second, any elapsed time? It is always going to be negative 10 meters per second squared all the time. Emphasis on all the time, provided you're at the Earth's surface. Number 19 I have to do, and we'll look at this. How far will a freely falling object fall from rest in 5 seconds or 6 seconds? So let's look at time equals 5 and time equals 6. And I remember how I said in class that we should be writing VI, VF, AT, and D. So velocity initial, velocity final, acceleration, distance, VI, VF, AT, D. Oh, yeah, T. So I will go ahead and erase that. Cool. Alright, so VI, if we're at rest, the initial velocity is 0 meters per second. Time is 5 seconds. The final velocity, I don't think we care about it. I'm looking at the problem number 19. How far will a freely falling object? So final velocity we don't seem to care about. If it's freely falling, though, we know it's a projectile, so the acceleration is going to be -10 meters per second squared. And the displacement is what we're looking for in both of these. So how far there and how far there. So it equals -10 meters per second squared. Final velocity we don't seem to care about, and that's going to be 0 meters per second. In both of these, you're going to use the equation D equals VIT plus 1/2 AT squared. And we're just going to be plugging and chugging. VI is going to be 0, so that's all 0. And we can kind of ignore it. So displacement equals 1/2 -10 meters per second squared times time, 5 seconds, all squared. On a good day, 5 squared is 25. Second squared is second squared. 1/2 of -10 is -5 meters per second squared. So I said in class that we can do the algebra anyway. This is another way of doing the algebra. And that equals D. So I just took this 1/2 and distributed it over the 10. And it will distribute over everything. So 1/2 times -10 is -5. You don't really have to worry about doing anything to the 5 because you're already doing the 1/2 to the 10 and it kind of takes care of itself. Or you could divide by 1/2 on both sides. You could do a lot of stuff, but I think that for our sake, this is the easiest way to deal with it. So -5 times t squared. -5 times 25 is -125. And if you look, second squared at the bottom, second squared at the top, you're stuck with the unit of meters, which is a displacement. That negative means it's going which way? Good, down. Same deal here. For time is 6 seconds, so displacement equals VIT plus 1/2 AT squared. Same equation. This is the only equation that we've got to deal with that has dA, VI, and T. dA, VI, and T. So VIT, that's going to be 0 plus 1/2 A, it's -10 meters per second squared, times T squared, which in this case is 6 seconds all squared. So 1/2 times, and you can do it, we'll do it the other way. 6 times 6 squared is 36 seconds squared, times -10 is going to be -360, and then we can play with some units here. The seconds squared go away, so it's going to be -360 meters. And I know I said that without actually writing it down. Shame on me. So this will be 36 seconds squared times -10 meters per second squared. Seconds will cancel, times 1/2. And I said on this one that the units will kind of even themselves out, and I just want to show you how. So at this point, the seconds squared have canceled out. -10 times 36 is -360. That times that gives you -360. The unit's still meters. Times 1/2. That will give us -180 meters. Again, falling down equals your displacement. And if you look here at the extra second, you fall an extra 55 meters, which is kind of cool. Or 65 meters. 55 meters. 55 meters. So, there you go. Hope that one helped for number 19. Another one I have to do for us is number 21. How far will a freely falling object have fallen from a position of rest when its instantaneous speed is 10 meters per second? So now, VI, VF, A, T, D. Again, they're asking us how far. So we're going for a displacement again. And this time they're telling us it fell from rest, so we start out at 0 meters per second. But the final velocity is what they give us. From a position of rest when its instantaneous speed is 10. So I'm assuming it's negative 10 meters per second because it's falling. The acceleration is negative 10 meters per second squared. Oh, sorry for that little. So, and the time is kind of irrelevant. They don't give us one. They don't seem to care. We don't ask about it. So now we need the equation that deals with VI, VF, A, and D. And what I would do if I was us, I would say, let's go with the VF squared equals VI squared plus 2AD. We know that's going to be negative 100 meters per second, all squared. I'm just kidding, not negative 100. It will be negative 100, but not yet. Just kidding. Negative 10 meters per second equals VI squared, 0 meters per second squared, which we know that is going to be 0, plus 2 times negative 10 meters per second squared times d, which is what we're looking for. So this guy goes away. 100 meters per second all squared, 10 meters per second all squared gives us 100 meters squared per second squared. That's what happens when you square the meters, you square the seconds, that's the unit you get. Which is wacky, but it'll go away in a few minutes as we start canceling stuff out. So 2, the 0, this guy goes to 0, you get 2 times negative 10 times d. So negative 20 meters per second squared times d. The next thing we do to just isolate these, divide both sides by negative 20 meters per second squared. Negative 20 meters per second squared. And this is the denominator of a denominator, which goes to the top. This is the denominator of a numerator, which goes down there. Either way, you're going to have a second squared on the bottom, a second squared on the top. This meters will cancel out one of those meters. So you're stuck with a d that's 100 over negative 20, which last time I checked is negative 5, and the unit is meters. You get a displacement in meters. When the object is falling 10 meters per second, it has fallen 5 meters. There you go. 23, it's a word problem sort of. What does the slope of a curve of a velocity time graph represent? Well, if it's velocity versus time, we're talking about meters per second versus seconds. So meters per second versus seconds. So rise over run is actually meters per second times seconds, because both seconds are on the denominator, and second times seconds is meters per second squared, which is acceleration. So what does the slope of a velocity time graph equal? Acceleration. And we'll see these coming up in the next couple of days. 25 I have to do for us. What is the appropriate equation for how fast an object falls from a position of rest? So we're looking for how far, for a good equation for how fast, I would say VF is a good one, equals VI plus AT, provided you know the time. And then for the displacement of it, I would say D equals VIT plus 1/2 AT squared. Again, because you know that's going to turn to 0. All you need to know is how long it's dropping for, and it will tell you how far it drops. 27. Looks like I have to do this one as well. Calculate the average speed in kilometers per hour of Charlie, who runs to the store 4 kilometers away in 30 minutes. And we need to go from kilometers in 30 minutes to kilometers per hour. So we know it's 4 kilometers in 30 minutes. And then you set up your goalposts. We're okay with kilometers because we want kilometers per hour. But we know that minutes we want to get rid of. And last time I checked, if you want to get rid of something on the bottom, you got to put it at the top. And if I want to go from minutes to hours, look, that's exactly what I want. So the question is how many hours in minutes or how many minutes are in an hour. So I know 1 hour is 60 minutes. 60 minutes. So 4 times 60 divided by 30 gives us 8 kilometers per hour. For part B, calculate the distance in kilometers that Charlie could run if he maintains that average speed for an hour. So now 8 kilometers per hour times 1 hour. The hours will cancel. I am left with an answer in just kilometers. And the answer is 8 times 1 divided by 1 is 8. So if you run 8 kilometers for an hour, you'll go 8 kilometers. So there you go. 29. Calculate the instantaneous speed in meters per second at the 10-second mark for a car that accelerates 2 meters per second squared from position of rest. This just got complicated. VI, VF, ATD. So we are looking for the instantaneous speed at the 10-second mark. So I know my time is 10 seconds. I'm looking for my instantaneous speed, which is essentially my final velocity from something that starts at rest, 0 meters per second. So, and it is accelerating at 2 meters per second squared. So VI, VF, A, and T, forget about D, I guess. So I would say the best equation to use with this is going to be VF equals VI plus AT. VF equals 0 plus 2 meters per second squared times 10 seconds. And seconds squared on the bottom, seconds on the top. Those two will cancel, so this seconds will cancel with one of those seconds. I'll end up with an answer in meters per second, which is good. 2 times 10 is 10, and my final velocity will be 10 meters per second. So I hope that's good for us. Oh, okay, I can't. 2 times 10, you're right, I'm happy I was looking funnily, is 20 meters per second. Even the big guy's wrong sometimes. So there you go, 29, 20 meters per second. Number 31, let's take a quick look at this. Calculate the instantaneous speed of an apple that falls freely from rest in a position, from a rest position, accelerates 10 meters per second squared for 1.5 seconds. So one more time, VI, VF, ATD. VI I know is at rest, so 0 meters per second. Final velocity, calculate the instantaneous speed of an apple, so I guess that's what we're looking for. A is negative 10 meters per second squared. Time is exactly 1.5 seconds, and D we don't care about. Same equation, VF equals VI plus AT. VF is what we're looking for. VI is 0 plus negative 10 meters per second squared times T, 1.5 seconds. That seconds will cancel with one of those seconds, so I'm stuck with meters per second. And again, this time I'll do the math right. The final velocity will be a negative 15 meters per second. Finally, number 33. Calculate the instantaneous speed and distance fallen for an object that falls freely for 8 seconds. So I'm looking for two things. VI, VF, AT, D. We know it's from rest, 0 meters per second. VF is one thing we're looking for. A is negative 10 meters per second squared because, again, it's freely falling. Time we know, 8 seconds. And the displacement is also something we're looking for. So we're going to actually have to solve two different equations here. First one for VF, let's do the easy one. VF equals VI plus AT. So the initial velocity is 0 meters per second plus a, which is negative 10 meters per second squared times 8 seconds. Once again, I hope you're picking this up at this point. That seconds cancels with one of those seconds, and the final velocity will be negative 10 times 8, which is 80 meters per second. So it's about the size of a football field every second. And for the second part, we're going to go d equals VIT plus 1/2 AT squared, because I know I just solved the final velocity, but I'm not positive of it. But I know we're dealing with a speed at rest. I know what our acceleration is. I know what our time is. So d VI 0, AT, I know these. So I feel much better about using these numbers than the one that I just kind of figured out. So we're going to go 1/2 times negative 10 meters per second squared times t, 8 seconds, all squared. PEMDAS, please excuse my dear Aunt Sally, let's do these parentheses and exponents first. 8 squared is going to be 64 seconds squared times negative 10 meters per second squared. And the cool part here is those second squareds and those second squareds cancel. Half. So now, I'm just going to extend this page down. So now we're sitting here at 1/2 times negative 10 times 8 squared, which is 64. So the answer is going to be something meters. So negative 10 times 64 is 640. Carry the negative down. Times 1/2. So that would be 320 meters. Negative. Because that was a negative and that was a negative and it was falling. So to answer the question, the displacement is negative 320 meters and the object is going at 80 meters per second negative. I hope you guys caught that. I just forgot to bring it down. So there it is. That was the homework. Sorry if you did the evens and I did the odds, but it could be worse. I hope this helped you, and if it didn't, I apologize. But I'll see you tomorrow.